Thank you all for joining us. I think that it's often the case that when we think of AI, we tend to think of the material, of the abstract, of the ethereal, and we have heard a lot about the cloud and the algorithm. In this panel, we'll be a bit more concrete and we'll go down to the physical infrastructure that is required for AI, and that is no other but the data centers. Data centers have been around for a few years now, but AI has been a game changer as the energy needs are increasing a lot. For reference, for one ChatGPT inquiry, it's about 10 times the amount of energy that a simple Google search requires, and the estimation is that by 2030, the energy needs of AI will be around the total of the current energy needs of Greece, of Portugal, and the Netherlands altogether. So we're going to experience a huge surge in energy needs, and in this panel we have an amazing set of speakers from both policy and the industry to help us explore both the opportunities and the challenges that lie ahead for a future that is both growth-oriented but also sustainable. So we're going to introduce our speakers. We have Nikos Tsafos, who is the Deputy Minister of Energy for about 9 months now, and before that he was serving as the Chief Energy Advisor to the Greek Prime Minister after a very impressive track record in major energy projects, mainly in the US. Then we have with us Vassilis Karkatzounis, who is the Secretary General, Secretary, I'm sorry, for AI and Data in the Ministry of Digital Governance, where he previously served as a legal policy advisor. And he's a lawyer by training with a specialization in IT and data law. Then we have with us Dimitris Kouklakis, who is Senior Vice President at TÜV Nord Hellas, with a track record in the private sector in oil and gas and infrastructure projects. And last but not least, we have with us Stergios Statharas from kIEFER. He is the head of the energy market analysis at the company, with experience in energy market simulations and green PPAs. So we're going to start with Minister Tsafos setting the scene on the fact that we see in the other side of the Atlantic many worries about the fact that households and SMEs neighboring big data centers, they witness a major increase in their energy bills. Is it something that we should be worrying about in Europe and especially in Greece, or are there any differences in the structure of our energy markets making us more resilient to them?
Well, thank you very much for having me. Thank you for this question and the opportunity to talk about this topic. You know, I think that a lot of the discussion around energy use and data centers and AI is very US-centric, and therefore we have a US-centric view of this problem. When I look at it from a Greek or a European angle, I see a few important differences. One is we've had electricity prices in Europe increase substantially over the last few years. If you look at the consumer price index across all the EU, relative to 2019, it's up 47%. So the average consumer in Europe pays 47% more for electricity than they did in 2019. Most of this, if not all of this, was driven by higher natural gas prices in response to Russia's war in Ukraine and the decision to cut gas supplies to Europe. So we're starting from a very different point of departure of much more elevated electricity prices, but also a fundamentally different driver for why electricity prices are higher. In the US, by contrast, what we're seeing is that the grid part of the cost is rising as the US builds out more grid infrastructure. And so we have a fundamentally different point of departure about why electricity prices have risen and how much they've risen. So that's, I think, one. The second thing is that the scale of the build-out in the US is just fundamentally different than what we're seeing in Europe and certainly what we're seeing in Greece. You know, when I look at maps of data centers the size of Manhattan, you know, that's not the data centers that we're building in Greece, certainly not, and certainly not what we're building in most of Europe. So I think where we are is we're probably a few years behind in terms of the curve where we're seeing data centers on paper of that scale. If you look, there are certain countries where the proposed data center demand is as big as the country. You know, Spain has talked about this publicly, where if you add up all the data centers, you need to build another Spain to meet the demand. But you're not actually building those data centers yet. So I think we're all just trying to see this wave coming. There's 3 or 4 countries where data centers are a significant portion of demand. Ireland is one of them. There's a few others where, you know, you're seeing data centers driving electricity growth. In most of the rest of Europe, we're not quite there yet. So I think it's a problem that we're identifying, we're seeing coming, but we're not feeling yet. And so that also gives us a little bit more of an opportunity to react and to plan better for the type of demand that might come. But I think at this point, there's a big gap between proposals and real projects. And there's also, I would say, still a big uncertainty about how these type of investments impact an electricity system. Are they flexible? Can they be flexible? What impacts do they have locally versus nationally? A lot of questions that I think we're still learning more and more as we proceed with these investments. So we're not worried yet, but it's something we're paying a lot of attention to be sure that when these investments materialize, we're ready for them.
Great. So now we see that Greece, Europe, and the US have a difference in scale, as well as in the timeline of implementation. However, Greece does plan for the deployment of almost 40 data centers by 2030. And whereas they are quite energy hungry, there are key arguments to make that their net benefit in terms of societal and economic aspects are worth it. So would you like to elaborate upon the reasons as to why we should not be hesitant and make the leap to direct a portion of our investment strategy to data centers?
Yes, of course. Thank you very much for the invitation, and apologies for me being delayed. I think that the conference is a victim of its own success, so it's very difficult to find a parking spot. So first of all, I'm not an engineer, and I profoundly respect people who manage the grid and who model these impacts. So everything we do on a policy side in the Ministry of Digital Governance, of course, has to be grounded in the energy system reality and not just ambition. I think balance is the principle that we keep returning to. I think that both overinvestment and underinvestment in data centers carry real risks. If you assume that explosive AI demand is coming and you build too much power or computational power too quickly, then there is a risk that you end up with stranded capacity in the energy grid. And on the other side, if you underestimate this trend and it proves durable, in fact, you lose competitiveness and the fair share of the digital economy. So I think that there is a balance that we need to find between the amount of investment that we actually need and the investment that is actually, the market is now at this point willing to make. What we see from our studies today at this point is that data centers actually account for less than 1% of Greece's energy consumption. This is, as the Minister said, substantially different than many other European countries like Ireland. This is even below the global average of electricity consumption. And we believe that the risk-benefit balance remains favorable, provided, of course, that we manage growth with discipline and not just enthusiasm about what is coming. So I think that the strongest argument in favor of investing in data centers at this point is that when it is done responsibly, the economic value created per kilowatt in AI activities can offer substantially higher return than in many other traditional uses. And this is exactly because AI raises productivity, it supports high-value services, and it attracts also international capital. AI-intensive infrastructure is what we call a multiplier for higher-value economic activity. And they did not only consume energy, but at the same time, they enable sectors like health, finance, mobility, many sectors that in Greece have a great potential of even further growth. And of course, when it comes to public sector, because this is also something that is of high interest to us, how we can have data centers that host public sector data, not only sensitive categories like health data and many other data that after classification we want them to remain in Greece for various reasons. It is also very important to highlight the digital sovereignty aspect. We believe that it does matter at this point. In the emerging AI era, we think that countries that lack compute infrastructure, either on a national or a European level, they're going to lag behind. They're going to be highly dependent on external actors, and this is something that has an impact not only on data and financial aspects, but also it might have an impact on democracy and how freely we make our political decisions. So I think it's very important, keeping a balance, but actually investing in data centers. We need to see the value besides the sheer economic value, but also on a political aspect.
This call for balance and for sensitivity, I guess it's in the center of the activities of stakeholders like TÜV Nord that come into play prior to the deployment of a data center investment through advisory to many players in the market, as well as through the certification processes. I'm wondering how are the rising energy demands of data centers playing into your activities? How have you seen the shift from the needs of data centers 10 years ago to now? So if you'd like to tell us a few words about the impact of this change in the nature of data centers through AI.
Hello, everybody. I wish to thank you for the invitation, Mr. Minister, General Secretary, Mr. Statharas. Nice to be here with all you guests. Before moving to the answer to your question, let's introduce a little bit TÜV Nord to everybody, maybe to the generation YZ, who is participating mainly to this event, is not a very known organization. TÜV Nord was founded in 1869 by the Steam Boiler Association. And wow, it goes before 200 years, but as steam provided a perspective to the world, now AI is also giving a positive perspective to the world, maybe having the same impact like steam before 200 years. During these years, our company evolved. Now we are active in more than 100 countries, employing 15,000 people. Our main tasks are certification, inspection, in accordance with international standards, technical due diligence, honest engineer activities for infrastructure, oil and gas projects, also like data centers. And we also provide training and certification services for personnel. Since 2001, we are certifying data centers in accordance with European standards. We have also created our own methodology, and based on this methodology, we have certified over 2,000 data centers globally. Just recently, in October 2025, we acquired EPI International, a company located in Singapore, which is also providing certification services in accordance with the US standards. So by this way, we strengthen our position as a global leader in the data center certification world. Moreover, we wish to point out that as TIFELAS, we are participating to an important initiative called Greek Data Center Association, and with our international experience, we contribute to the development of the data center sector in Greece. Before moving to sustainable efficiency discussion, which is the core of this panel, we wish to point out why certification is important for the data centers. Certification brings additional value to the developers and securing their interests and the interests of their clients, is mitigating risk, downtimes. It's helping the data centers to improve, to find gaps in their design. And finally, certification empowers the data centers to operate in a sustainable and efficient way.
Great. I keep this idea of the need for incentives to make this transition as green as possible. And I would like to move to your experience at kIEFER, and you're now building a data centers in Greece. You already have your first as a proof of concept, and within the next year, you're anticipating the deployment of the first few. And you're focusing a lot on the existence of PPAs as a mechanism to ensure that the energy needs are met in a sustainable way. Would you like to say a few words about your experience with this mechanism and the challenges and the opportunities that arise with it?
Thank you for the invitation here, and congratulations on this GenAI event. I want to go and mention three aspects that give synergies and opportunities for the development of data centers. It's the co-development of data center along with renewable energy, and synergies that can be harnessed if we deploy also energy storage systems. So we see that by collocating BESS with RES and signing a PPA, we can harness this cheap green energy to source data centers. And if we combine two more attributes, the first one is flexibility that can be given from AI, from smart scheduling AI workload. More services can be offered by the data center ecosystem, improving the whole economics of the development of data center. And alongside with energy storage systems, we can have a complete solution that can not only match the load needed from RES, but also provide flexibility services and auxiliary services to alleviate the neighboring grids. So we see there an opportunity as kIEFER, and we are investing on data centers along with RES.
And as a follow-up, another worry that exists in the US and in specific states, of course, featuring an entirely different scale of data centers, is the risk of blackouts and extreme pressure on the grid, as data centers are not just very power hungry, but they're also power hungry around the clock, essentially. Would you like to say a few words about how these three mechanisms can help alleviate this pressure of the grid, or do some sort of prioritization in specific times of the day? Because we do see that operators take initiative in order to alleviate the pressure when they see fit.
Yeah. Actually, between the US system and the Greek system, there are some structural differences. For example, those congestion costs that are created from specific concentrated vast loads are allocated to specific regions and may directly pass through final consumers. Here in Greece, there are differences. For example, we have a zonal pricing instead of nodal, where we have a wider area that smoothens those congestion peaks, but along also with existing legacy grid assets, and in places where, for example, there is a strong grid due to deligitization, for example, areas, data centers can be co-developed with RES in existing grid and harness all this green energy, which is cheap, and alongside with the flexibility asset that I mentioned before. Actually, the main workload of AI, which is can be separated into non-time critical, such as data pipelines, batch inferences, and things like that, and can be allocated due to daytime, so to harness the full potential, for example, of solar photovoltaics. And this is going to match physically in 24/7 resolution the RES generation. How? With also co-installing an energy storage system that either, if it is of the aspect of hybrid RES, that can provide from the beginning the appropriate profile to the data center, energy profile, or collocated to the data center that along with UPS can provide those flexibility services, shape the load, be charged from green energy surplus, and also provide some more, let's say, benefits, like from a direct PPA between the RES and the data center. We don't have curtailments if it's a physical PPA, and we have a guaranteed price securing the revenue streams to the RES asset, as well as cheap energy to the data center that is finally passed to end consumers through cheaper tokens, cheaper services of AI.
I assume that all these initiatives play into the way that data centers become certified. And I was wondering, amidst the climate of increasing suspicion towards this sort of sustainability trademarks that different investments do get, how do you tackle the concern of greenwashing through this sort of certifications, and what are the key mechanisms that you leverage in your work in order to ensure that the grading and the classification matches with the energy footprint of the data center?
If I understand correctly the question, you are referring to false sustainability reports. And yes, it's something that we are facing in the latest years, not only with data centers, also with the famous upcoming production of hydrogen, let's say. So a lot of companies are playing with the words, are playing with the numbers to show that the technology is, let's say, more sustainable than it really is. So the European Union, with implementing some new regulations like the EU taxonomy and the new European Efficiency Directive, they are trying to control this behavior of companies by implementing certain rules. First of all, we have measurable sustainability. And data centers must meet strict thresholds for energy efficiency by providing numbers for power usage, water usage, real numbers in comparison to their installed IT or cooling capacity. Another measure is the implementation of reporting and verification, which is an obligation for data centers above 500 kilowatts starting in 2026. Okay, this is also subject to the regulation of each country. In Germany, it's above 300 megawatts. In Greece, it's still something that we have to decide. Another measure is that the transparency about energy resources. There is a new mechanism that controls really from where the power comes, and it's not based on maybe vague reports or certificates. It's not a game of declarations anymore. It's transparent through audits. And another measure is that data centers, they have to prove best practices like waste management, wasted heat reusage, or refurbishment of equipment. These are measures that are helping everybody to, the whole procedure to be more transparent and the whole system to trust that we have a clean data center environment.
The reliability of the certification relies to a large extent on the existence of data that can inform us and guide us through this process. So I would like to tap on the data angle of your portfolio to discuss a bit what sort of data are we currently lacking on the energy needs of data centers, and what data do we currently have and work with.
I think that transparency in these matters is both reasonable and necessary, especially as this kind of infrastructure is becoming more and more critical. There is a very thin line on what type of data we're asking for here, because there are, as anyone can imagine, there are lots of trade secrets involved. And the way that these models are, both the data centers, the technology behind the data centers, but also the way that they perform for specific models, like the HPC architecture and aspects like that. Obviously, there is a high risk of exposing trade secrets. And this is a very interesting debate that we saw unfolding in the general purpose AI code of practice in the European Union, not for energy. This was an aspect that was not directly addressed, but we saw it in many different aspects. Where do you strike a balance between what information can a company provide and to what extent it can be limited for trade secret purposes. Copyright and the type of data that is used for training LLMs was part of that discussion. So I think that for all of us, having more transparency in data is a matter of trust and planning accuracy. I might not delve into technical details about what exact data we need about such circumstances, but I think that our approach should obviously be a tiered approach, and it should be bundled with certain assurances and safeguards for the companies, because I think that in such cases, as European legislation, as the Data Act indicates, there are two different things. Companies must feel comfortable that sharing specific and very detailed data is done in a safe manner and not in a manner that will undermine their competitive advantage. But at the same time, the state should be able to ask for such data freely at any point so that it can make informed policy decisions. So I think that's again, a very fine line that should not be crossed for companies.
Thank you. I think that this point on data, it touches upon the broader discussion on how can we create a climate, an ecosystem that is friendly for investments in data centers. And one key factor that really is a game changer when it comes to the deployment of data centers is the licensing processes. And I'm wondering how is energy fitting in the picture of license giving in our country, and whether do we see specific hubs, regions, areas being prioritized in this process?
Yeah, well, thank you. If I can build on the three answers we heard just now, I mean, the two key things for me are good quality data so that we can understand what impacts data centers have on the system, but also making sure that we can have flexibility and other solutions that come from data centers, right? So if you can provide service to the grid, if the waste heat can be used to, heat an area, these are all very important things, and I would say we're still learning of the full scale of how these data centers will integrate in the future with these systems. Now, for Greece, I think there's a couple of things that we need to keep in mind. One is, the reality is that our grid is just now getting revamped. Basically, because of the economic crisis, for 10 years, we underinvested in our grids. And we're coming out of this sort of 10-year period with a 4x increase in investment in our grids between 2019 and 2024. That, by necessity, means that we may not be able to accommodate quite as much interest in quite as many locations as we would like, because the system is still getting revamped from a decade of underinvestment. But there's one specific use case which I think is quite interesting, which is what we're seeing PPC wants to do in Western Macedonia. And essentially what they're doing is they're taking the old lignite areas and they're trying to build an ecosystem of energy solutions to power a data center. What does this ecosystem mean? It's solar, it's batteries, it's pumped hydro, so essentially a battery and water, a conventional gas plants, waste to energy. So what you're seeing is essentially an ecosystem of solutions that will be able to feed the data center, and so covering the needs of the data center, and then sort of also be able to play with the broad grid. So in a way, you have almost like a microgrid that meets the needs of the data center, and then when there is surplus electricity, you can send that into the grid. So it's a way to look at this problem not just as I put a data center here and I expect the grid to feed me. It's I create a whole package of energy solutions that can meet the needs of the data center, but also potentially play well with the rest of the grid. And I think that kind of innovation where you're not just putting something and expect the system to accommodate your needs, but you're trying to figure out how do I create an ecosystem of solutions that can supply both the needs of the data center as well as the needs of the broader grid. I think that is a very interesting use case that we're working with PPC to make happen, both from an energy perspective, but also because obviously as part of our broader just transition strategy for Western Macedonia.
And it's not just the private sector who is operating infrastructure for AI, as Greece is currently building its first AI factory. So would you like to say a few words about how energy demand and sustainable and this need for sustainable meeting of these needs is fitting into your model for Pharos? Which we should note that is being built in Lavrio, very close to the urban grid. So, yeah.
Yes, exactly. So, yeah, we're launching Pharos, the first AI factory in Greece, and of course it's built around a supercomputer. You cannot have an ecosystem without a supercomputer. And energy planning has been treated as a core parameter when planning for Daedalus, the supercomputer. We try to build in efficiency and sustainability features right from the beginning. That includes modern HPC architecture, advanced cooling systems, and of course on-site solar panel to partially offset the daytime load. Of course, that's not enough. We need, everyone knows that we need more advanced systems. We need energy storage. There are many aspects that cannot be immediately covered, but this is something that we're working on. Another interesting aspect is that sustainability actually is a pillar of Pharos. So we're trying to leverage AI for energy efficiency. This is a priority, is one of the 3 pillars. We are conducting studies to see the grid's ability to support the data center load in Lavrio, because besides Daedalus, we're going to have a data center sitting right next, so traditional CPUs sitting right next to the supercomputer infrastructure. And if I may add on what the Minister said, the geographical distribution is essential. Exactly, this is the reason because we saw the opportunity in Western Macedonia for Pharos as well. So the second supercomputer, the public supercomputer Pharos X, is going to build in Kozani as well. And I think that this is a personal view from the data that we have available. I think that for private and for public sector to keep selecting Attica as or Creta as their main options for data centers. In my opinion, it is not ideal. It is not optimal. We should think about a more careful strategy, how we can incentivize data centers built in other regions of Greece. Western Macedonia is a great example, but still, even that, we see that there is currently a lot of interest. We might want to think a bit more forward. And just a note that energy is a critical factor for building data centers. This is the reason why it is very reassuring that many energy companies are interested in that. PPC is a great example, but it's not the only parameter that is being taken into consideration. And this is interesting because if you see a comparison of current grid availability and the investment interest, they don't match because there are other aspects. There is broadband connectivity, there is a proximity to urban centers, there is security, the acceptance of the local population for such investments. So there are many issues that one has to take into consideration to carefully adjust such investments.
Great. Dimitri and Stergios, from your experience from the industry, do you feel that, because we kind of focused a lot on the negative side of data centers as power-hungry structures, and I was wondering, do you have some optimism on data centers potentially being part of the green transition of the country?
May I answer first? Of course, data centers are not only bringing new issues to the grid system, but all have to do also with the responsibility and the approach of the data center developers. Let's connect, let's say, the investment to the social impact of data centers. We go again to certification standards, but EN, for example, 50,600 imposes 4 levels for availability for data centers. And we can see that starting from the low availability to high availability of data centers. And we can see the impact of a higher investment, which secures a higher availability data center. We can have many advantages to the economy. High availability data centers help critical organizations like government, hospitals, the army to be always connected for critical activities. Help by mitigating downtimes. We save water and energy by designing efficient data centers. We help the grid because we avoid the big changes in the demand, and we also save energy. And at the end of the day, data centers secure that, for example, education platforms, kids everywhere around Greece have access to education programs. So data centers definitely have a bright, sustainable future and can create a certain future for the country.
Well, in kIEFER, we see data centers as a great opportunity. We already have signed 2 PPAs to green source data centers in Megalopoli, 20 megawatts. And this is an opportunity in many ways. First of all, as I mentioned before, you have a secure load to source your green energy, which, if it's co-located, will not be curtailed. This guarantees the revenues for the RES assets in 2 ways. Not only physical curtailments that in the last year has increased very much, but also to market-induced curtailments, meaning the negative or the zero prices. There you have a guaranteed price and guaranteed energy to funnel your data center. So from a developer side, from RES developer side, this is a great opportunity. From also the software as a service side, for example, we have developed Sophia AI, and this needs training, this needs inferencing and things like that. By developing data centers, which we funnel with our cheap green energy, we can harness synergies such as the very cheap tokens and very cheap service at the end of the day. So these are 2 great opportunities working in synergy, and also getting to know this technology and positioning early and harness all the benefits.
Great. And to wrap the panel up, in this race for AI, every country is trying to find its niche and its leadership role to position itself. Greece, as a small country, I guess it's quite hard to be a leader in terms of innovation and research and the development of tech. But I was wondering whether the immense progress we've done in renewables, whether this could be leveraged to put us in a more competitive place, both regionally and globally, in this AI race.
Absolutely. If you look at the Greek energy and the Greek electricity system, we think we've made tremendous strides over the last 5 years. Just to give you a few data points, if you look at the bigger picture, 20 years ago, this was a lignite-heavy country. 60% of our generation was lignite. And now 60% of our generation is solar, wind, and water. Right? If you take the solar and wind part at 50%, that's one of the highest percentages in the world. As a share of generation, solar and wind put us 7th in the world in terms of penetration. The other thing is, Greece has become a net electricity exporter. 5 years ago, we imported almost 20% of our electricity needs. Last year, we became a net electricity exporter. Net electricity exporter also means that everything else being equal, you have cheaper energy, cheaper electricity than the people you're exporting to, right? So we've gone from a world where, if you look in 2019, our electricity price at the wholesale level was 70% higher than Germany and 35% higher than Bulgaria. Right now, it's cheaper than Bulgaria and only about 15% higher than Germany, right? So this dynamic growth of renewables is not just changing the direction of travel, where we used to import electricity and now we export it. It also means that we used to have to draw electricity in and pay a higher price, and now we are the source of that electricity, so we have a lower price. And at the end of the day, if you look at the number one problem that I have in my job, maybe not the number one problem, but definitely top 5 problem, is there is too much investment interest in renewables in Greece, and there is not enough demand for that. So if you look at how much electricity we consume and how much electricity people want to invest, on average, it's about 25x. So there's 25 times more electricity interest to generate that there actually is, on average, demand in the country. So anything that can increase the demand side of the equation, if it's done well, if it's done at the right location, if it's done with the right safeguards, can be a real boom in terms of our ability to attract more investment in renewables and generate this electricity, and to do this for the benefit of Greek society and the Greek economy. So that, I think, is a very good story that we're trying to communicate, and why we think this transformation that we're doing on energy is going to have ripple effects all across the economy.
Great. On this optimistic note, we'll wrap it up. Thank you very much, and thank you very much for your attention. We'll be watching closely.